Sir, so can I have a brief introduction about yourself? How is your journey from Oregon to the Scott Associates?
To what associate? Oh. Well, I've been involved in my own business for a couple of decades now.
Mm-hmm.
I was a technical director for a restoration company down in the San Francisco area, doing a lot of consulting and overview, building investigations, etc. And then came up to work for an architectural firm
Oh,
in Tacoma. And then our own business continued as a investigator and also as an instructor for my building science thermography course. Been doing that again for a couple of decades.
mm.
And then now at senior building scientist at Vapor Shield.
How to you? I mean, like how you came to know about this technology, sir, in the initial stages?
Earlier on, in somewhere around 2000, FLIR introduced I guess it would be inexpensive at that point. Prices have come down on the infrared cameras. They were still
Mm.
$15,000, but it was at a price point and small enough that people could actually use them, infrared imagers. The company that I was technical director for reached out to FLIR, said, hey, we're applying it to restoration, looking for water, et cetera, as well as one of the members of the company was a consultant for building investigations.
Mm.
So the company got a contract with FLIR to do their training for building applications, all the training for FLIR. And I wrote the manual and did the presentations for them. That started in 2003. So that's how it started. And the
Okay.
investigation and putting together that course, et cetera, obviously gave me a lot of background and knowledge, as well as the hands-on and the experience in the consulting, investigation in buildings.
Okay. Have you faced any significant challenges, sir, while learning about the thermography technology?
Uh, the only challenges is the requirement of the learning. Earlier on in 2006, I was one of the original creators of an organization. It's a nonprofit called the International Association of Certified Thermographers.
Okay.
One of my students at FLIR called me up and said, hey, I've got this class that I'm putting together. It's a 2-day thermography course that will train home inspectors on how to do infrared thermography in buildings. And I said, okay, and your background is you took one class from me, and do you consider yourself an expert? How can you create a course and actually teach it for home inspectors? And so this organization is to look at the quote unquote certifications for different applications of thermography. It's got 3 groups, one for medical thermology, another for condition monitoring, which is predominantly what all the organizations teach you on how to use the infrared camera, and building science applications, of which I'm the director of. And that's kind of the issue in the early beginnings is, do you have enough knowledge to actually interpret? Oh, this is easy. I can push the button and take a pretty
Mm.
picture. Well, it's much more complicated than that.
Mm.
Yeah, moisture thrown out on carpet or wet walls are not too hard, not too difficult. It's when you're looking for energy exchange and airflow and other anomalies that you see with the infrared. How do you interpret that? How do you adjust your infrared camera in order to see those patterns more clearly? Do you have the appropriate equipment? Is your resolution good enough? Is the thermal sensitivity good enough? So there are a lot of hurdles to achieve in order to get a true, clear understanding of what you're seeing with the camera.
Okay. So moving forward, I'm having a few questions which I prepared for my project work. Can I just go ahead and ask them?
Oh, please go ahead.
Okay. Related to the technology, I mean, like what it aims to solve and its values. The key challenges that are in identifying the hidden energy losses in the buildings, such as heat leaks and the insulation gaps. What are the key challenges that you faced while finding these challenges?
Well, if you're looking at uh, gaps in the insulation, is that what you're talking about?
Yes, sir.
Okay. Well, there is another stupid test method. There is an ASTM test method. I'm on two different committees, so I can get away with saying that. um, there is a test method out there that provides a summary on how to do that investigations. You've got to have temperature differential, which is the key to all heat exchange, conduction, convection, and radiation. Without a delta T, there's no heat movement, therefore you don't see any patterns. You've got to see the studs. Oh, is there enough heat transfer in order to see thermal bridging, which are the studs in the system, in order to see the patterns of the anomalies of the insulation. So in that aspect, that is a fairly easy application as long as the conditions are appropriate. One of the issues that I see, especially with home inspectors, is an inside audit. Interior of a building, there are all kinds of stuff on the wall, from paintings to drapes to chairs, couches, etc., that get in the way of viewing the wall surface itself. There are other issues in regards to temperature differential. The way we heat the interior of the building is to heat the air. If the air is not constant, is not consistent in its heat, say we go into an extremity in the basement and the temperature is different, the patterns are going to be different on the wall. So there are some issues in looking at insulation specifically. Then if you want to look in airflow, that's a whole different study.
And where you find this issue most of the time, sir, like old buildings or the new ones, or the ones which are in the colder regions? Where do you find this issue mostly?
Well, okay, you're speaking about cooler climates. You got to get off of that because there is energy exchange that occurs in Phoenix, Arizona. It's very, very hot. Air conditioners. When the power went off in Texas, people died because of the temperature differential. In Chicago, decades ago, people died due to the heating, the urban effect, et cetera, in Chicago. They didn't have air conditioners. So it's not just the cold environment. We focus on the cold environment because, all right, it's cold in the wintertime and we don't like being cold, but we also don't like being very, very hot. So there are climates in both hot and cold that are issues and problematics in thermal resistance, conduction, convection, and radiation. So in the cooler climates, you're going to see patterns as long as you have a delta T. In the heating climates, you're also going to see a delta T. So you've got to have that temperature differential in order to see the pattern. In the cooler, in the wintertime, in climate zone 6, 7, and an 8, you have a good strong delta T. It's cold outside and warmer inside, and you're able to see the patterns. Whereas if you in Phoenix, pretty much all year round, as long as you have air conditioning, you're going to get a delta T, but it's hotter on the outside, cooler on the inside.
And before the thermographic technology, how you used to solve this issue, sir? Like, what are the traditional methods you used for resolving this issue?
With thermography, what do you mean resolve the issue?
I mean, like, before the thermography technology is introduced, how people used to identify these air leaks and the insulation
Oh,
issues.
yeah. With air barrier installations and requirements in the codes, we're looking at air exchange. So the biggest was, oh, the building's leaky. Where? It's a visual effect and visual issue. Without thermography, you're not able to see. What you need now is to focus in on, let's see, I helped train the Army Corps of Engineers back in 2008, 2009. And the biggest implementation of air barrier and air tightness was looking at the design details. Are the designs for the air barrier continuous? Do you have to lift your pencil up? If you lift your pencil up, it's not continuous. And so we focus on the design details. Do you have a continuous air barrier? Then we implement those design details with the contractors. So, yeah, who's responsible for the wall to roof connection? That's a good one. Is it the roofing people? Is it the wall people? So you need to observe the installation and monitor the installation to ensure that it's airtight. And then obviously at the end, does it seem visually that all the air barriers are tight? With the bringing in of thermography, you can do that more at the end, though it's almost too late because you've already built your wall up, and visualize the impact of air exchange as long as it's got a delta T or temperature differential.
Okay. So can
But
we?
it definitely brought in a better visualization with the use of infrared thermography and with the pressure differential so that you can see the air exchange.
Okay. So you are saying like with the use of we can use thermographic technologies during the construction of the buildings also, so to monitorize the heat gaps and all. I mean like during the what to say while working also can we inspect using the thermographic cameras?
As long as you have a temperature differential. The problem with building and constructing a building is that its system is not usually built in the beginning. So you're going to have to use visualizations. As I mentioned, the design details are critical, and then the construction is critical. But during construction, you don't have the delta T typically in order to visualize, nor do you have all the walls and the air barrier installed to get the airflow to see where the gaps are. You need to do it visually. There are some applications of thermography, especially in the northern hemisphere, the south side, with the sun shining on the quote unquote insulated walls. You're able to see, you got a delta T. You're able to see the pattern differential, but forget the northern side because the sun doesn't shine there. So again, it goes back to the fundamentals of thermography or heat flow. You've got to have a delta T in order to have heat flow. In order to visualize it, you have to have heat flow with infrared thermography.
Sir, if you don't mind, I have a basic doubt in between. I mean, like you have been mentioning a term like a delta T most of the times. Can you please explain a little bit about the delta T?
I'm not following you.
Actually, in our entire conversation, you have mentioned the delta T like more times. Delta T means that it's a temperature differentials, right?
You've got to have a temperature differential
Okay.
in order
I
to
just
see the
wanted
pattern.
to cross confirm that.
Yes, yeah.
Okay.
Heat flow, Q equals Ka delta T over L, HV delta T. All the heat transfer equations require a delta T in order to have heat flow. You've got to have heat flow in order to see the patterns. If you don't have a temperature differential, it's all the same pattern.
Okay, sir. And is there any additional challenges other than the environmental conditions that you faced while conducting the thermographic inspections?
Well, I mentioned the biggest, and that's delta T.
And that the interior
So,
furnitures and all are also a difficulty for you. And else than that, is there anything else that you want to include?
well, besides operation of the camera,
Mhm.
you need to understand how to operate the camera and tune it. A lot of these imagers, especially the inexpensive one with lower resolution, will overlay a visual image. A visual image is totally different than a thermal image, and it will confuse the viewer on what's actually going on. You can see through glass with an overlay of the visual, whereas in thermal, the long wave imager, 7 to 14 micrometers, cannot see through glass. However, with the overlay, it looks like you're looking through glass. So there's a lot of confusion aspects of it. The resolution of these thermal images are pretty dang poor. However, with the higher resolution and better thermal sensitivities, you're able to see more patterns. Oops. You're able to see more patterns in the result. You got to wave your arms, do you?
Just 1 minute, sir. I,
There
I'm so sorry for that. I'm
you
at
go.
library, so
Yeah, yeah. It sounds like it's got an automatic shut off if you don't move.
I'm so sorry for that.
That's all right. I was in a new building in Palo Alto, California,
Mhm.
and the design requirements for the city were that all the offices, et cetera, had to have sensors. So if there was nobody in the room, the lights would go off. Well, if you sit at your desk and you're not moving a lot, the lights go off, and you got to wave your hands.
So sorry.
Anyway,
And how thermography compared to the traditional energy efficiency methods? I mean, like how it is comparable, like related to the accuracy, cost, or the labor equipments. What would you say? Like, I know thermography is a better option when compared to the traditional methods, but what are the positive aspects that we can consider over that?
the positive bring that by me again.
Uh, we know that thermography is much better than the traditional methods to visualize and stuff related to the cost requirements and cost accuracy and the labor requirements. How will you address that thermography is much better than the traditional methods?
Well, what do you mean traditional methods?
Like the
There's
physical
no,
inspections or the
well,
air fluid
they have to
tests.
go hand in hand. You can't throw one out
Okay.
and just use infrared. You've got to use all of it. That's one of the key issues with infrared thermography. You've got to use critical thinking
Mhm.
when you're utilizing thermography as well as your eyes. That's why I did the distinction when you blend visual and thermal, you're confusing the issue. So you've got to also use your eyes and
Okay.
visualize and understand. You've got to look at the design details and understand the building environment
Mm.
while you're using infrared. You've got to understand that you're looking at an exterior wall. You have to understand where the enclosure around the conditioned space is, because it may not be the outside walls of the building. There may be a vented room or utility closet that shouldn't be conditioned or semi-conditioned. A parking garage is a great example. Is a parking garage open to the outside? Well, yeah, you drive into it. And so the envelope, the conditioned space, needs to surround the parking garage to separate the conditioned space. So all of those considerations need to be involved and to understand what you're looking at. And once you understand what you're looking at, that's appropriate. Temperature differences are appropriate. You're not seeing shadows due to sun shining on it or thermocapacitance issues, diffusivity for the wall structure, brick, etc., has a thermocapacitance and it will heat up and then slowly cool down, which will give you patterns and result. Shadowing by trees or buildings. So there's a lot of complex issues that you need to understand while and during the thermal viewing. And then you take your thermal viewing, as I explained, and all the parameters and understandings of just the thermal pattern, what you're looking at. Are you clearly seeing it? Is the resolution poor? Is the delta T such that you can't really see the patterns very clearly? So there are a lot of complex issues. Can it be resolved and done? Yes. In fact, I think it should be implemented, and it is in some cases. The DoD has a specification in the that I helped write a decade or so ago in regards to the requirement of what the thermographer has to have in order to inspect the air barrier situation when you're doing a pressure test. And that is they have to have a level 2 certification that emphasizes building science. I don't know, did that help?
Yes, sir. And I'm just so much concentrated.
That's all right. That's why you're in the education, learning.
Yeah. I mean, like it is quite interesting, so I'm just keep on learning, listening. I'm
Hey,
sorry.
at this age, I'm still learning.
That's a good thing. What a- And do you think is there any current gaps with the thermography technology? I mean, like I know every technology is like not 100% accurate. There might be like
Hold on one
sure, sir.
second. All right, can you still hear me?
Yes, sir.
Okay, good.
Yeah, what I'm asking is, we know like not every technology is 100% perfect. There might be some gaps which they are, yeah, I mean, like even though they are resolving, there might be some gaps. Do you think is there any current technology or the upcoming technology which can be more accurate than the thermography technology? Or I'm so sorry.
That's all right. So you're talking about accuracy.
First of all, not exactly about the accuracy. I just wanted to ask, do you think there are any limitations for the thermographic technology?
Well, I mentioned a whole bunch of limitations.
Okay. How do you
It-
think that we can overcome them? I mean, like, is there any alternative technology or the upcoming like advancements or the upgrades which can resolve that issue?
Alternate technologies, there is coming into the market sonic,
Ultrasonic.
whereas you put a, uh, a, a loudspeaker inside of a building that's at high frequency and then a monitor on the outside, and it's actually able to put um, the leak or the sound onto a visual image.
Mhm.
And so it's not thermography, but it's using sound transmission.
Mhm.
That is becoming more and more available. In fact, it's merging in with thermography itself.
Sir, what do you think after a decade from here? Can you think that ultrasonic technology can like replace the thermography?
No,
No.
no, you got your eyes,
Mhm.
visual, which are very important.
Okay.
You've got your thermal, which is also important, and now they're bringing in sound waves, et cetera, which transmits. Um, if you look at the wavelength spectrum, sound aside, because sound's a pressure wave, not an electromagnetic wave, you may be able to see differences with devices that detect ultraviolet, et cetera, but the physics just don't seem to pan out in regards to transmission. Um, there are uh, radio waves that they're using that they're able to quote unquote see through walls and movement on walls, X-rays, etc. But the problem with that is you're using um, a high energy wave that affects humans, and the cost involved
Mhm.
uh, in X-raying, et cetera, in order to see patterns. So maybe in the long run something will come in, but thermography is a non-invasive, non-harmful detecting device. Whereas when you get into the smaller wavelengths, now you start to come into issues even in ultraviolet with uh, damaging, um, etc.
Okay. And do you think that adopting to the thermography technology for a new company is like a high initial investment for that?
The cost of the infrared cameras are starting to come down. We're seeing some of the imagers coming in from China that have pretty good cycling time. They're up to, oh, did I see, 30 megahertz or thereabouts, and their resolution are quite high. There's a new software programs that many of the thermal imagers use, and that's uh, the Google phones or the iPhones utilize this, and this is where you overlap images, visual or thermal, on themselves to increase the resolution. So the night view with your cell phone camera overlaps a whole bunch of images, and when you're taking an image, you're slightly moving, And so those overlaps increase the resolution. They're doing the same thing with infrared thermography to enhance it. So the industry is moving to more and more applications to help enhance the thermal image. Prices are coming down as more and more people are buying it. Though with we'll see what happens in the next 4 years with the tariffs. Things are going to
Pretty
get pretty
crazy and
crazy and
crazily
crazily
expensive.
expensive because of the new administration.
Okay. And sir, as you mentioned, the thermography technology, I mean, like to use that camera to be an operator, it requires a little bit of specialized training and a certification. Can you please elaborate a little bit on that? I mean, like, is there any prerequisites that a person should have or something like that?
Yeah,
Yeah, as I mentioned, the DoD requires a level 2 thermographer. In the United States, unfortunately, we tend to look inside versus outside. There are ISO standards for infrared thermography that are much more defined and required than the interior, well, and the ASNT guidelines for infrared thermography. The ASNT certifies at the level 3. They don't certify at the level 1, level 2. They only give guidelines and examples. And in those guidelines and examples, they typically include in the States only the use of infrared thermography in conditioned monitoring, looking for hotspots for electrical, hotspots in mechanical. They don't get into the building science applications. Even with the ISO standards internationally, they don't typically get into the building applications. They only get into the thermal applications for looking for heat in condition monitoring. Same thing with medical applications. The bigger companies, GE, et cetera, do not want to implement thermology into medical applications because it's less expensive than their huge MRI machines and equipment that are millions of dollars in some cases. Um, so it's a very complex issue. My my understanding and the reasons why I have my own personal training in class is it's both building science and thermal science. You've got to understand building science, heat flow, airflow, and moisture flow, in combinations with understanding conduction, convection, radiation, and how the camera operates, in order to understand how to get the
Mhm.
patterns and what do the patterns mean in relationship to a building. The unfortunate thing with many people see an infrared image of a wet area and they go, "Oh, this is easy." But they forget that you've got to have that delta T. No delta T, you're not going to see patterns. So it must be all good. There's no patterns involved. Whereas if you had a delta T, oh my goodness, there's no insulation here. So there are a lot of attributes that you need to learn in order to properly um, describe and understand the operations, let alone the patterns that you see.
Okay. Sir, so what kind of students you get most of the times at your institute, like the college grads or the industry professionals?
What people do I teach?
Mm-hmm.
Yeah, predominantly now, because I'm no longer associated with FLIR,
is
is
architects.
architects and engineers and consultants. They're my predominant marking at. They all understand that I am the quote unquote professor of thermography, that I'm able to teach them properly versus these other training centers in the United States that will teach you the fundamentals of infrared thermography, but not
Direct
the direct
application in the
application
building
in the
science.
building sciences that need to go hand in hand. So, for instance, in 2 weeks, 2 weeks now, wow, time's going fast, 3 weeks, I'll be teaching um, a contractor group in Vegas. They're coming to Vegas, and I'll be teaching a handful of those individuals on how to use the infrared thermography. They are the QA of the contractors. They're a team a national organization that are of contractors that get together and understand how to QC a build or a building. Um, in January, I'll be instructing a new building consulting group in ARM in Atlanta and their team on how to use the infrared cameras and applications in building consulting and then the applications of thermography in that.
Okay, sir. I'm almost done with my project questions. I just wanted to ask you, with your experience and with your looking after the all this industry experience and all, would you like to give any suggestions to the new persons who are entering into the market? I mean, like new grads like me.
Would I like to do
Any
what?
suggestions or any advice that you can suggest us that how we should be like entering into the market?
How you yourself
Should be
should be
trained and
trained
understand.
and understand thermography?
Not exactly about the thermography, about the life. What is your understanding of the life? What a professional should have while entering into a market? I'm an international student. I came here to for an education purpose. So, what would you suggest for the people like us?
Okay. Let me back up a little bit and talk about the architectural
Mhm.
education. In the architectural education, they teach you how to draft and draw and make pretty
Yes.
pictures.
The
Yes,
background
the
and
background and knowledge of the building sciences, et cetera, is important, but it's not as emphasized in that particular market. So you've got a lot of these highly skilled professional individuals in the academics that go through, now I'm just doing architectural schooling, that don't understand the thermal science or building science even building science
Mhm.
applications, and they're building buildings. They need to understand clearly the fundamentals, in my opinion, of the sciences of building. Is not just the fundamentals of, hey, you got to understand codes, you've got to understand the engineering aspects of the wall, you got to understand how to make a building beautiful. Ugly buildings don't last. Um, so in that aspect,
the
the
educational
educational
programs
programs
still
still need to focus on some of the fundamentals. You yourself, looking at infrared thermography, need to look at thermal science, and there's really a limited thermal science in the
Mhm.
academics. I'd love to get into the
academics and
academics
teach
and teach
formal
thermal and building sciences as a whole. Usually the engineers that I speak to that are quote unquote trained in heat transfer and heat flow and thermodynamic properties don't really understand the criticalities that are required to use infrared. They understand the science, they can repeat the equations, but they don't understand the nuances of the applications, as I talked about this
Mhm.
morning. Um, the requirements for delta T. How do you get a delta
Mhm.
T? The thermal capacitance of the wall systems, the heat transfer differences, thermal bridging issues with wood stud versus metal stud fasteners, et cetera, that now look at the building side of it as well as the thermal side of it. So the basic science is important, but the nuances of those basic science and how they apply to things. You could be an expert in
Mhm.
physics and still not get the applications of infrared without the understanding of the building sciences in combination of the two.
Obviously. So I'm done with my questioning session. Thank you so much.
Finally, no, I'm just kidding. I'm just
Uh,
kidding. This is great. I
I'm so
love this.
sorry. I just took your extra time. I understand.
No,
It's
no, no,
really
no.
valuable for
Please
everyone.
don't apologize. This is important for you to reach out and get knowledge like this on somebody who actually has hands on in the understanding.
Thank you so
This is
much.
great.
And I really learned a lot of things today, and I understand how complex it is to have a thermography technology. While I'm doing my project, even I thought like it is a bit simpler than the other technologies, and it is okay. And what I thought is we can go over the traditional methods, but I learned really valuable lessons today, which is really complex, and it is not. I mean, like it should go hand in hand with the traditional methods and stuff. So thank you so much for your valuable time, sir.
Yeah, please keep in
Sure.
touch. I'd like to see what you do in the future, as well as if you ever have any questions or whatnot, just pop me a line.
Okay, sir. Thank you so much, sir. Have a great day.
You too. Take care. Good luck on your
Thank you,
future.
sir.